Okay, so this is the last video I'm going to do on solving tan equations. There are definitely two ways to solve this equation, so we could actually sketch both of these functions individually and determine the points of intersection, which would be a great way of tackling this if you are doing this on a tech-enabled exam or anything like that. Instead, I'm going to solve this just working through it because it is going to work out with a nice solution. So the first thing here to notice is that sine 3x and cos 3x. So because they have the same angle inside them, we can group them together to make the tan function. And the way I'm going to do that is just by dividing by cos 3x on both sides, because we know that sine over cos is tan. So if I divide by cos 3x on both sides, I'll have sine 3x over cos 3x equals -1. Because this was negative, it has to remain as -1. And sine 3x over cos 3x can be simplified to tan 3x. So after doing that, we're looking for where tan of some angle is equal to -1, and should be thinking at this point that, well, for tan to equal 1, that has to be an angle of pi on 4. For it to equal -1, we're looking for the second, fourth quadrant equivalents. So the second quadrant equivalent is going to be 3 pi on 4, and the fourth quadrant equivalent will be 7 pi on 4. I probably should specify a domain for this, so I'm just going to make it 0, so x is an element of 0. I might just make it 0 to pi, why not? Do something a bit different. Okay, I'm going to still write down a few more solutions, and again this I guess just comes down to a little bit of experience with this, but if x is an element of 0 to pi, then we know that 3x, which is the angle that we have, is an element of 0 to 3 pi. So this is almost a 2 pi. I'm going to go and keep on going. So I'm looking for another second quadrant angle. So after 7 pi on 4, we should get 11 pi on 4. Notice the difference here is the same in each case. It's one of the nice features of the tan function. I shouldn't need to go any further than that, because the next one would be outside of the 0 to 3 pi domain that we have come up with. So when I go and divide both sides of the equation here by 3, I end up with, well, that was a bit out of place, x equals, so 3 pi on 4 over 3, the 3's should cancel out, just leaving pi on 4, 7 pi over 4, and the 3 goes down the bottom, so we get 7 pi on 12, and it's also going to be 11 pi on 12. And these are our three solutions, which are all within our original domain of 0 to pi. So there we have it. That's solving the tan function. It works in much the same way as the sine and cos functions. And again, it comes down to knowing the table of exact values. If we know those values, then we can know how to solve these things fairly easily. Anyway, I'll leave that there, and we'll get on to the graphing.